This week has been pretty bleak for energy transitioners. Prices are high in many parts of the world. Tens of millions of homes in Spain and Portugal lost power at the end of April. A lot of people will believe that we're going too fast.
We're halfway across the road. Now, if you've ever seen anyone hesitate crossing a multi-lane highway, that is a very dangerous thing to do. The best thing is to get right across as quick as you can.
I think this gets us to the really meaty part of our discussion, which is about how you go and fix the grid.
You can run a very high proportion renewable grid incredibly reliably, but you don't do it like you did the old ones. Markets have got to move at the same speed as technology and engineering innovation. At some point, you start saying, should we open up a debate that involves the demand side as well as the supply side?
And that's a real-life social science experiment that you went off and conducted, right?
1.6 million households signed up. All we had to do was text them saying, tonight, earn a little bit of money by shifting your demand by an hour. What we got was the equivalent of turning off all of the electricity in 2 major cities.
This message is different to a lot of the people who have talked about the renewable transition over the last 10 or 15 years. A number of the advocates are promoting it in a way that is very ideologically driven, that is probably not very persuasive, frankly.
We signed deals in 8 of the biggest house builders in the UK to build homes where there will never be an energy bill. We shouldn't try to convince people this. We should be able to show it because it's available right now, right here.
We're joined by Greg Jackson, the CEO of Octopus Energy. The company is only 9 years old, but truly has enjoyed exponential growth. It's the largest electricity provider in the UK, and it serves tens of millions of homes worldwide through its software platform. I'm a happy customer, and I've been stalking Greg for several years. Delighted to have him here. So today, we're going to try to make sense of the Iberian blackout. Tens of millions of homes in Spain and Portugal lost power at the end of April, and dig into how we future-proof our future grid. How can we make sure they deliver clean energy safely, or is that not going to be possible? So Greg's an expert here. Greg, the glass-jawed grid, like a boxer that just falls over at the sight of the opponent. What happened in Spain and Portugal?
I mean, look, first of all, we should be clear that we don't know yet. Looking into major events like this, which have usually got multiple causes, takes time. And we have to let the orderly process of investigation go on. There was a major blackout that affected a very large region of the UK, including some of the southeast or most populous regions in, I think, 2019. Investigations into that, and it was a less serious event than Spain and Portugal. Took many, many weeks, and facts are still emerging down the road. So look, let's be really clear about that. But I think we can draw a few generic lessons, and there have been kind of comparable events. I mentioned one in the UK. I think in 2016, South Australia had
Right.
a very major blackout with some very similar looking characteristics, in that case caused by storms, with some characteristics in common. And of course, we've seen them in Texas as well. And what they've got in common is an energy island with very little interconnection. So I think only about 3% of Spain's total capacity is available via interconnectors.
And Texas famously, ERCOT, the land of the free, does not connect to anyone.
No, I think technically there is actually a little bit of connection, but it's very, very, very skinny.
Right.
And Australia's got a similar thing, energy islands, because obviously it's the geography of Australia lends itself to that. So the first thing is energy islands. The second thing is lack of batteries. And I think this is really big. Essentially, you can run a very high proportion renewable grid incredibly reliably, but you don't do it like you did the old ones. And
Yeah.
we should talk here about market structures as well. But one key feature of Spain's grid is, I can't remember how, it's got like a fraction of a gigawatt of batteries.
Yeah.
And actually very little planned in the pipeline. If I compare that to, for example, the UK at the moment, the UK has got 5-6 gigawatts of batteries, and it's got plans to get to 10 or 20 times that. And the last bit, I think, is a lack of digitization. And I think it's shocking around the world how undigital grids are. We put smart meters in people's homes, but most major substations or components of the grid are not metered in real time. There's not much telemetry. And then we rely upon sort of manual control rooms rather than automated systems to balance the grid.
You step back there. Let's step back to Spain and Portugal, right? So I think, as you say, we don't know the original cause of the incident that day. We know the proximate cause, which the proximate cause was that over the course of a couple of seconds, there was a frequency wobble, and that caused things to trip and then power to be shut down. And that frequency wobble I found fascinating as I started to dig into this a little bit. So, grids in the US run at 60 hertz, at 60 cycles a second. In Europe, it's roughly 50 hertz, maybe 49 in some cases. And the grid is this massive machine where you have dozens, sometimes hundreds of traditional fossil fuel turbines spinning. These turbines are enormous, 300 to 400 tons, some of them. And they build this inertial kinetic energy within them. And if there's a spike in demand or there's some problem with supply, the inertial energy in those rotating turbines is enough to smooth the grid out. And so you rely on the fact these massive machines are spinning. And I found it fascinating that a 0.15 hertz deviation, we don't know exactly what was the cause of that, was enough to bring the Spanish grid down. And what it seems to be that in other grids that are not as renewable as Spain, I think when we started recording this, Spain is 73% renewables. It's a hot, sunny day in May, and there's probably a bit of wind going on. You don't have so many turbines spinning, right? That seems to be the kind of proximate issue.
So around the world, the frequency of the grid, it was kind of it was served for many purposes. It was an artifact, a product of the fact, we had these big spinning generators. Now, part of the physics is when there's a very high load on a grid, the rotational speed of those generators slows down. And that's a signal that you need to put more generators on the system, right?
Right.
So essentially,
But you're sort of bleeding energy, the inertial energy off to kind of keep the grid running. Is that
so basically, just the physics is when you've got a high load on a generator, then that high load essentially acts as magnetism and stuff, right? But acts as drag on the speed.
right?
When you see your generator slowing down, when you see the grid frequency dropping, you know you need to put more electricity onto the grid to
Hmm.
reduce the load per generator, right? Essentially. So that was the feedback loop you could literally use to control the grid in the old days,
Right.
um, in an
So can I just
analog
that
world.
sounds very odd. I mean, I'll give an analogy here. That's a bit like if you go into a traditional car, there's a speedometer and you can tell how fast you're going. In this version, you don't have a speedometer. You drive the car into a person and then you work out after the fact that you were doing more than 25 miles an hour.
Well, you know
It's
what?
it's sort of a bit like that, right? Because you're not actually you're measuring the actual thing, not the thing that tells you what's happening.
Yeah, I think it's complicated, right? The simple thing is, if you keep an eye on the frequency in a traditional grid, you know whether you've got excess load or indeed insufficient load, right?
Right.
It's an automatic feedback loop.
Mhm.
In a renewable grid, the electricity is not generated by things that are spinning. So what happens is you can't any longer rely on the old analog system that the frequency is the signal for what you need to do. Instead, you need digitalization and access to, you need to be reading what is the load digitally, and you need to be able to respond digitally. For example, by using batteries to be able to either soak up power or dump some onto the grid quickly to maintain that kind of supply and demand balance, of which the frequency is an indicator.
I've met a couple of grid people in my life. I mean, I'm proud of this. The grid operators in the UK, and I've met some involved in the US. They seem to me to be incredibly smart and thoughtful, methodical people who are thinking quite hard about grid resilience, and specifically grid stability. How do you get into a situation where everybody understands the physics, they understand the engineering physics, they understand what the amount of inertial energy there is in the system, it's measured in sort of gigawatts, seconds, or something. How do you get to a stage where you allow that resilience report resource, that dampening resource that exists, to disappear without putting systems in place to make up for it?
So first of all, we should say that, look, some of the most committed, dedicated, and smart people I know include grid engineers.
Yeah.
The sense of mission, professionalism, and dedication, plus absolute technical expertise is off the charts. Let's note that. I think there are a couple of features of any transition. The first one, by the way, is the assumption that we need a grid of, say, 50 hertz, the European figure, right?
Right.
Because if you like, in the traditional grid, where the frequency was a byproduct of how we were generating it, as way which we controlled it, everyone's alarm clocks used to run off the grid frequency. Obviously, these days they don't. They've all got microprocessors and use internet signals and stuff like that. On the whole, the equipment that relies on the grid frequency now is going to be things with big motors, especially a large industrial equipment.
Mhm.
And at some point, you start saying, should we open up a debate that involves the demand side as well as the supply side? And this applies to so much stuff in the world of energy, by the way. And I'd love to talk about some more of those. And saying, like, over time, rather than having this kind of religious dedication to extremely tight grid frequency, heavily synchronized across the entire system, are we going to open ourselves up to a grid which has flexibility in that world as well? Now,
Mm.
because
Can I
you
just
might,
say that that is super fascinating, and it reminds me slightly about why the old apocryphal story about why train tracks are as wide as they are, and the joke is it's the width of two horses' backsides dating back to the Roman Empire, right? So we engineered around a particular engineering configuration, and path dependence has kept us there. But I think this gets us to the really sort of meaty part of our discussion, which is about how you go and fix the grid, right? Is it software? Is it markets? Or is it just going to be more steel? And I think this week has been pretty bleak for energy transitioners out there. Of course, we had this situation that in Spain and in Portugal, Tony Blair, the former UK Prime Minister, came out and said, look, net zero strategies are going to be a real problem because they've got quite ideological and the politics won't support it, consumers won't support it. And in a way, the energy transition and net zero have become deeply interlinked, right? Prices are really high in many parts of the world, particularly in the UK. A lot of people will believe that we're going too fast, that this is happening helter skelter, and you can understand why that is.
okay, so first of all, the last thing on that grid issue, I
Yeah.
was going to say was I didn't really answer your question about the engineering.
I'm
And
sorry. Yes, please.
yeah, no, I was going to say is we've got to remember all these things are run by markets. And so, for example, one key feature of the Spanish market was that with batteries, you couldn't stack different revenue sources for a battery. So you only had one revenue source. Whereas in the UK, you stack different revenue sources. You get paid, you make money by arbitrage in the grid, you make money by
Right.
balancing the grid, by responding, by reacting to frequency issues. And because you can stack the revenue in all these different ways, batteries are much more financially attractive here, which means the
Mhm.
engineers have got more tools in their box.
Right.
Whereas in Spain, the engineers don't have access to that tool because the market hasn't provided the incentive. And so, very often, this critical moment of transition, which you're kind of referring to,
Mhm.
we have a world where markets have got to move at the same speed as technology and engineering innovation, and it's not happening. And then you get consequences like this.
I'll come into that point about markets because I think it is a really fundamental observation, right? So the old electrical system was incredibly expensive to get into. You needed £1 billion or the equivalent. You needed to be friends with the Secretary of State or a cabinet minister to get the permit. And then you had to connect into the grid. And then the market was sort of designed, and there's a whole academic discipline on the design of electrical markets. And it does seem like there's a whole set of new assets that are emerging. For example, couldn't frequency reserve, right, be a tradable asset that becomes like a financial product that you can invest in, you can get a rate of return on by saying, look, I'm going to be there and I'm going to ensure at these moments that the frequency will always be met. And that will turn into some physical asset, which might be, a battery or something else.
Yeah, and essentially, by the way, that is what some grids have. You get paid for helping, for example, sort out frequency issues.
Right.
There was an interesting thing we had in the UK where we've got this technology platform, Kraken, that
Hmm.
drives Octopus, but manages. So, I mean, by the way, to give you an idea about the amount of data in the modern grid, today in the UK alone, Kraken processes 300,000 rows of data per second.
Right.
That is 30 times more than Visa, the payments network, globally.
Wow.
And so energy is very rapidly moving from a world where you had very little of this kind of real-time data to a
Hmm.
world that is astonishingly data-centric. And that's the way in which you can sort of manage a lot of problems we're talking about. So you can manage the physical problems that would help reduce the risk of something as happened in France, in Spain and Portugal. But it's also how you deal with the economic problems that Tony Blair rightly highlights. The biggest offshore wind farm in the UK is paid to turn off 71% of the time it could be operating. And what that means is, and because we don't have a dynamic way of managing
Right.
to use the electricity that's available in a renewable world when it's available, the kind of theoretical, the sticker price for electricity from that is about 7 or 8 pence a kilowatt hour.
Hmm.
But the effective price per unit delivered is more like 27 or 28 pence.
Right.
And
Because it's
it's,
turned off two-thirds of the time,
yeah,
essentially.
and it's getting paid to be turned off. So not only you've got an idle asset, you're literally paying for the units you didn't get. And then you have to pay someone else to generate them. We're at a stage in the energy transition when a lot of the kind of rigidities of the old world are causing the physical problems you describe, in this case, the Iberian Peninsula, and also the economic problems that Tony highlights, Tony Blair. And so
Mm.
I think what we need to do now is not row back. Like we're halfway across the road. Now, if you've ever seen anyone hesitate crossing a multi-lane highway, that is a very dangerous thing to do. The best thing is to get right across as quick as you can. And
Right.
that's what we have to do in the transition now. And to do that, we need to be taking sometimes hard decisions and driving sort of really important change in how we manage the system. And so this digitalization, it's quite interesting actually. I mentioned earlier the South Australia grid.
Mhm.
After their very, very major 2016 blackout, they actually had this question: can we deliver a reliable grid as we're becoming more renewable?
Didn't they build that massive battery with
They
Elon
built
Musk down?
exactly built massive batteries.
Yeah.
But they've doubled down on renewables. They're now a 70% renewable system. And I think it's certainly one of the cheapest in Australia from having been one of the most expensive. By embracing this change and investing in the technologies for it, you end up in a cheaper and more resilient, reliable world. And so,
Can I take us to Texas for a second? Because
yeah,
I think Texas is really interesting. You know, it's the home of J.R. Ewing and Dallas and big oil, but it is also the most dynamic renewables market in the US and really, really allows for quite a lot of competition. I remember you telling me something about a product that you had in Texas, which allowed you to manage the demand of people's homes, which feels like it fits into exactly what we're talking about. That story to me is super, super interesting and really granular for people to understand what that future looks like.
yeah, it's honestly a great example. And first of all, by the way, what Texas has is relentless competition and the ability to build stuff. And I think that latter point is what's enabled them to really benefit from building out, wind and solar in terms of electricity costs. And by those low electricity costs have then changed the economy of Texas because they're attracting massive manufacturing because, among other things, they've got really cheap electricity.
Mhm.
And so one of the interesting things is you can get to virtuous circles
Right.
once you've crossed this road. Now, the product you're talking about there, I should set the scene really.
Yeah, please do.
Because the
Yeah.
inspiration for so much of the way we think about this is sort of conversations I have with my mum. Oh, I don't actually have them. I have them in my head. And I think, what would my mum say? And it started in the UK. And the UK's got a half hourly electricity market. So every half hour, the national price of electricity is set by the most expensive generator anywhere in the country that's needed to meet demand.
Yeah.
And uh,
Can I
uh,
just build on that for a second? So that's a really important part of the market design, which is every 30 minutes, you figure out how much electricity is needed, and people file in the cheapest first. And right at the end, for that last watt you need, is someone who's going to be really, really expensive, and that sets the price for the whole of the market. It's
that's right.
worked for years. It feels a bit odd now.
Yeah. Well, it used to work very well when essentially you had coal power stations and maybe a few oil and gas,
Mm.
where the input cost was very similar between all of them. So they would all bid in a very, very similar price, which meant even though you were paying everyone the most expensive price, it wasn't that much more than the cheapest.
Mhm.
Whereas in today's world, when you have renewable energy, there is no input cost. So you can achieve a very, very low price for energy from those units. But in a market where the price is still set by the final unit of generation, which will be gas, and has a very, very high input cost, typically in recent times, you're paying a fortune for stuff that should be cheap. That's the
Right.
kind of broad issue. And I think really getting your head around why the system used to work and now it doesn't is so key. And it's because there's much more heterogeneity, much more diversity of generation
Mhm.
than there ever used to be. And by the way, it goes geographically as well. Because, in the old days, you got a coal power station in a particular county. Whenever you want electricity in that county, you fire it up. Whereas in today's world, it might be windy in one part of the country, not another. It might be sunny in one time in one part, and so on. And we've got to handle that much more dynamic back end. But actually, this thing was my mum, right? It was a cold winter's evening, and National Grid in the UK, who balanced the system, were going to be firing up very, very expensive diesel generators in order to meet the high level of demand on a cold winter's evening. And I thought, most of that usage at the peak time is for things like cooking. Everyone's putting their oven on at the same time, a very big consumer. And then they're putting their dishwashers on straight after they've done their cooking. They've got their hot water going for,
Right.
you know,
For the
and
shower
so
and everything else.
everything, right? And I thought there's no signal to tell people that, they could benefit if they shifted their time. So nobody bothers shifting their time. And I thought if I said to my mom, hey, mum, tonight, and it's not because she's an environmentalist, by the way. I mean, I don't know actually when I don't know whether she is, but because she is definitely a bargain hunter. If I said to
Yes.
my mum, tonight they're turning on diesel generator to meet your needs, she'd say, well, I'll just cook later, right? For her, that is it's no effort, right?
Absolutely.
And so we introduced this program in the UK where, we paid people a small sum of money to shift their consumption out of peak times. And I think 1.6 million households signed up. And on average, more than half of them would participate. All we had to do was text them, sometimes just a few hours beforehand, saying, tonight, earn a little bit of money. I mean, literally, I don't know, 50 cents
Right.
by shifting your demand by an hour. And what we got was the equivalent of turning off all of the electricity in two major cities.
Right.
Um,
I mean, it's remarkable. And just to give you a sense, I mean, that's a real life social science experiment that you went off and conducted, right? This question about can you shape demand? And there was a lot of umming and ahhing in the press in the last 10 years saying, well, people won't do that. People make their tea when they make their tea. And what you demonstrated was actually people are willing to do that. I get those emails, Greg, and I charged my car 2 days ago at 50% off the already discounted overnight rate. So yes, thank you very much. I probably owe you a beer for that.
I mean, you can afford to buy it with the money you saved. Yeah, there's one customer tweeted me. He said that he charged his car for £1.90, and we'll
It's
be able
like
to do
$2.50 or something, right?
yeah, exactly. We'll be able to do 200 or 300 miles on it. I mean, it's mind blowing. The reason I mentioned this was just the thing we're doing in tech. What we found is every time we come up with a way of helping people save money by using electricity differently, some people do it, and sometimes it's a lot. But in the UK, we've got 7.5 million household customers, and about 60% of them have got a smart meter. So only 6% can do it. So we've only got about 4 million can do this. 2.5 million of our customers do these things. And look, it shouldn't be a surprise because it works in every other market. Like when you go in a supermarket, they'll reduce the price of stuff if it's close to its use by date, or if they want you to try it for the first time, or if one brand is introducing a new variant. Simple price offers are everywhere in our life, and it is mad that they're so absent in electricity in a world where electricity is now so dynamic. What we find is that literally on sunny days, there's a whole pile of customers in regional UK where the grid can't handle the amount of solar being generated. There's not enough capacity to put it onto the national grid. It has to be used locally.
Mm.
So we give people free electricity on sunny afternoons. Their consumption increases 400%
Yeah.
because they save their washing for those days, right? We do
I'm
it on.
thinking about buying one of those synthetic diamond presses. And on those sunny days, they require a lot of electricity. I'm going to mint artificial diamonds and then sell them on eBay.
I certainly know people who talk about doing Bitcoin mining at these
Right.
times,
Or
right?
train your large language model on the sunny days in July. So there's another bit of technology that we've talked about a lot within Exponential View. I discussed it in my last book, which was the idea of the virtual power plant, right? So people have got cars. The cars got 60 to 100 kilowatt hour batteries. You could use 10 kilowatt hours and power your house and four of your neighbors overnight, and you wouldn't notice the range. And this notion that you could string these car batteries together and all be in it together and contribute a little bit to providing some storage and some supply of electricity overnight or some resilience. It looked great on paper, but I would just wonder whether has it been a bit like the metaverse that it looked great on paper, but we didn't really deliver
No,
on it, and I just got too excited in my book.
it is the new normal. So, among our customers, we've got nearly 250,000 people who got an electric car and use a specific product. By the way, we've got another 250,000 electric cars that don't do this, but
Right.
there are 250,000 who they're signing up to a program where they get exceptionally cheap electricity for their cars. But all they have to do is when they get home, well, first of all, when they get their car, they pair it with us. So they use the car's app to pair it with Octopus. And that enables us to control when the car's charging. They set some very basic preferences, like a typical default would be I want 90% battery at 7 a.m.
Hmm. Have
Um,
you been in my preferences? Because that's where I am. Yeah.
there you go. I
Yeah.
think it's the default. It might be
Right.
80%. But
Yeah.
anyways, and then all they do is plug in when they get home and we'll decide exactly when it charges. They get the charge they want, but by us being able to control it automatically, it's not only grabbing electricity at the cheapest times, typically when it's windy and sunny, but it's also able to, for example, help balance the grid, help reduce the risk of the exact issues we've just been talking about. And in return, they get very cheap driving. So the scale of this is mad. In 3 years, we've gone from 0 to 1.7 gigawatts. Now, that's the equivalent of nearly two mid-sized nuclear power stations for free, right? Because basically this is a byproduct of the car. That's when cars, EVs, are only 5% of the fleet in the UK. So as you get towards, EVs being 100% of the fleet, this isn't a bolt onto the energy system. It is the energy system.
It's 20 or 30 nuclear power station equivalents. But look, let's get to this road crossing. I really love your description of it as crossing the road, and we've left one side. We're halfway across, and yes, there are all these lovely things on the other side of the road. There's the ice cream stand of the virtual power plant. There's getting cheap energy at this time, and zonal pricing, which means that I pay a price that's more appropriate to the cost of producing and distributing the electricity to me. All these market mechanisms that create financial assets, which allow the grid to work with a higher degree of efficiency and resilience. It's lovely, but there's still four more lanes of traffic that I've got to get across. So let's not sugarcoat. It's harder today, right? I mean, the technology is a bit of a tailwind, but what happens market to actually get across that road?
We're at the stage now where there are going to be winners and losers. So, for example, you mentioned zonal pricing, and more than half the electricity in the OECD is under some locational pricing model. It is the
Mhm.
norm. But as countries move to it, it means that, some of the generators today that get paid that high national price for every unit, even though they'd happily charge less, get paid less. They still get paid enough because they're getting paid above what they bid.
Mhm.
It's just they're not getting paid the very, very high national price. And by the way, that's why zonal pricing doesn't just reduce it for prices for people who live near the jet assets. It reduces prices for everybody because we're no longer contributing to such an inefficient system. For example, when a generator is in a low price zone, any electricity they send to another zone is also priced at that low price. So instead of today, where it's priced at the high price, and that's how everyone benefits. Now, governments that are grasping this opportunity are genuinely seeing lower prices for consumers. I mean, for example, great examples in Scandinavia, for example. But they're also attracting new industries, like big AI data centers, popping up in Norway, not because there's a big population, there obviously isn't, but because there's cheap energy.
Right.
But the challenge is a very big difference between energy and other sectors is the amount of lobbying. So traditional retailers didn't get to lobby that Amazon was unfair or that the internet was unfair. They just had to deal with this new efficient source of competition that frankly was better for some people than what was there before.
Mhm.
But in energy, energy is the equivalent of Walmart being able to go and lobby, that we've got to shut down the internet because it's unfair to us. Instead, I think what we need is governments that are able to say, look, we've already set climate goals. We shouldn't row back from those, but we can't expect people to pay more. Instead, actually, we should be accepting that renewable technologies are cheaper as long as we introduce the market reforms. And they've got to be brave
I
in
mean, there
pushing
was
them forward.
clearly a flaw in Iberia, which was to do with perhaps its systems design, right? There wasn't enough interconnect. They allowed this sort of reserve of inertial energy to disappear over the course of the 20 years where they've led in solar. And what's interesting to me is that those are like externalities. And a large part of the argument around renewables is that they don't have the same externalities that fossil fuel has, right, in terms of its carbon emissions. And it just strikes me that there's a certain amount of perhaps it's pragmatism, right? We sit at the start of 2025, AI data centers are booming. There's
Mm.
going to be couple of $1 trillion spent on building them out over the next few years, half of which will go into chips and a large part will go into producing the energy. The industry is demanding it really, really rapidly. Natural gas will be the natural swing resource, particularly in the US. Is there a space now for articulating this in a way that is perhaps not as, techno optimistic as we may have come from?
I was joking to someone recently that I'm not a good salesman, which is why we had to build Octopus to show, not tell. And I think showing rather than telling is the key. For example, we talked earlier about those electric cars, right? Using that smart charging, it is 6 times cheaper to drive an electric car per mile than it is to drive a petrol car. Now, politicians around the world worry about the cost of driving. We've had fuel protests, gilets jaunes, and so on. The electric car actually isn't about techno optimism because it's available right now, right here. And they're only now, I think the premium in the UK is they're 6% more expensive to buy than a petrol car. And some models are coming out where both the electric and petrol version are the same. It's basically price parity. They cost less to run. There's virtually no servicing. In China, by the way, an electric car is 20% cheaper than the petrol equivalent. So the technology is now here. By the way, the smartest form of electric charging we've got is where a battery and a car can go both ways. As you said, powering houses and the grid. If someone's got one of those cars, we give them 13,000 miles a year, 20,000 kilometers of free driving. We shouldn't try to convince people of this. We should be able to show it. And increasingly now, I was at just a child's birthday event recently, and one of the grandparents was there. They don't care. It was someone who isn't environmentalist or anything like that. And they told me the joy about their electric car because there's a retired couple, they bought a tiny electric car. He said, we've had it a year and a half and we've only paid for charging once. Because they charge while they're at a supermarket. They
Mm.
charge on the super cheap tariff at home. They've only charged out of home once and paid for it. And I think as people like that tell those stories, actually the lived experience beats the techno optimism. We are now building homes. We've signed deals in 8 of the biggest house builders in the UK to build homes where there will never be an energy bill because they have a combination of heat pump,
Right.
battery, and solar panels, and then use some technology to optimize that with the grid.
And you never
Um,
have to pay an energy bill again. I mean, that's part of, you're bringing that, weirdly, that's a Silicon Valley future, right? Which is abundance of energy, genuinely too cheap to meter. But this message is different to a lot of the people who have talked about the renewable transition over the last 10 or 15 years. And certainly the minister in the UK, when I hear him speak, Ed Miliband, what I hear is somebody who is first and foremost thinking about a political objective, which is net zero, rather than effectively a technological reimagining of the grid. The notion that it used to cost you $20 to take 24 photos and get them processed, and you only got 24. And now with digital, we can take 1 million photos. They're probably, even some of them are better than ones we used to take. That is what happens in a technology transition. Actually, we do benefit from a smarter digital two-way grid. It can be more resilient. It's certainly going to be cheaper. But a number of the advocates are promoting it in a way that is very ideologically driven, that is probably not very persuasive, frankly, compared to the notion of, I'm not going to pay an energy bill.
yeah, but I think, look, we've got to remember, take the internet, which we've both referenced multiple times as an
Right.
analogy, right? It originally came out from a military objective, which was how do you maintain secure communications, even in wartime conditions. The whole idea was how do you create a self-healing distributed network.
Hmm.
It then kind of merged with the academic world, where you could use it to join education institutions in higher education for research purposes. But when the private sector got hold of that technology, they were able to say, here's how we can use it to drive down costs, to create new products and services, to kind of revolutionize many parts of the commercial world. And it's very similar to this, which is, look, policymakers create the subsidy regimes and the policy regimes that first created the innovations that enabled us to get solar and wind and battery to anything like a kind of realistic, scalable solution. But now, in the hands of the private sector, we're able to innovate stuff that is better for consumers. And I don't in any way kind of begrudge the messaging around climate because that's what got us here now. But what has gifted us are innovations that can transform one of the most important sectors of our economy. Now, one thing I will say, though, is that one of the big differences between the internet and energy is the internet didn't have to really fight an opposition. There wasn't a sort of pre-existing thing that was trying to defend its turf. Now, you may have had that in little bits. For example,
There
the
was little
record in
bits. There was with the telecoms guys. I mean, I remember both in the US and the UK, they made a big deal about 911 calls and
that's right.
999 calls and saying you
Yeah.
won't be able to make them over the internet. There was definitely some resistance, but it wasn't as big as the multi-trillion-dollar business that was the oil industry.
By the way, it's not just the oil industry. The electricity industry, and utilities. In many countries, they're owned by or managed by governments, or the monopolies are handed to them by governments. And even when you've got a private competitive system, a lot of them grew out of government. So they've got these 100-year relationships with governments,
Mhm.
and governments run the rules. The rules of the grid are typically set by a government, which means the core strength of most energy companies is lobbying,
Right.
which means when change comes along, when it works for them, by the way, they lobby very hard for it. But where it's not in the interests of the existing solutions or providers, they lobby very, very hard against it. And so, I actually salute governments for the strength they've shown in kind of pushing this through. But we're now on that second half of the road. And the faster we get across the rest of the road, the safer we're going to be. Because at the moment, you kind of try to ride two horses at once. And that's really never very effective.
Yeah, I mean, I think that is exactly the complication right now. We're sort of kind of getting dressed, and we've got our rugby shirt on the top and our tuxedo trousers below, and we just look stupid as it is, and we have to just sort of finish that job. I want to leave with sort of a last kind of question about what you think might happen over the next 5 or 10 years as we continue down this road. Obviously, solar and batteries are very, very cheap. They're coming down in price. The economic case to buy them, even as a homeowner, is higher, and the electric vehicles will continue to progress, even if they're slowed a little bit by the new tariff regimes. Do you imagine we're going to see more of these cascading failures, more of these blackouts as we get across that road, whether it's in Western Europe or Asia or the United States?
20 years ago, 5% of global clean energy patents were Chinese. Today is 75%.
Right.
Um, Slowing down the move to electric vehicles to protect incumbent industries through tariffs or through regulation is literally guaranteeing you're missing the train for the most
Absolutely.
important technology transformation of our time, other than AI. All right.
Hmm.
So it is mad to condemn our companies, our industries, and I say that for many Western countries, to condemn them to essentially irrelevance. Instead, we should be spurring that change so they can be part of the emerging world. When you said we're going to see more of the issues like Spain or whatever, look, I think the failure to understand customers in energy really holds back policy. And you said we've done these kind of big living lab experiments at global scale. We need more of that. It's fascinating, one of the energy companies in the UK also provides broadband. And they said if a customer is hard up and has to choose which one they pay broadband because the internet is considered by customers more important than electricity for a short period of time. A customer said to me, look, if I haven't got power, I just open my laptop and watch a movie on Netflix, right? Because I've got a battery in there. And so,
Right.
no, Barry, I'm not advocating not having power. I'm just saying the assumptions of what people want and need are changing. And to create this kind of much more flexible, resilient grid, first of all, we need market signals. So we're building batteries everywhere. And then we need to understand customers. So when we pay people to shift their consumption,
Mm.
what we're really doing there is saying instead of having a random blackout caused by an inflexible system, we're allowing individual households to say, I'm okay without it for a bit and earn money and drive down their cost by doing so.
Great. There's so much in here. I mean, I love the focus on the customer. Many of us will remember what energy companies have been like historically, and you see it in their net promoter scores and so on. That's pretty unique. I think the other thing that's so interesting is how you have been able to address this collective action problem actually without the sort of structures of a government. You've been able to get people to work collectively in a number of different geographies and in different ways, responding to that incentive. And of course, there is the digitization that is really so fundamental to Octopus. The thing that puzzles me for my very last question: why an octopus?
Well, look, first of all, I can't help but respond to your thing about that digitalization. Look, the point really being, so much of our new consumption, like electric vehicles, is totally flexible about when and where we
Mhm.
use it.
Yeah.
You know, in fact, there are loads of people who could go for a week without charging their car. And therefore, if it's not windy for a week, they are very, very happy to fill up beforehand and then just use the electricity they've already got. That's the world we're emerging. And the reason I mention this, we used to think the way to build a safe car was to put more steel in it and make it more and more rigid. And what we discovered was crumple zones,
Mhm.
right? By making it more flexible, it could be safer. And it's the same with our energy system, whether it be the expense of the UK or the sort of supply resilience that we saw in Spain and Portugal. Flexibility is everything. I mentioned the internet. We both mentioned it. It is successful because it is decentralized and flexible. And
Mhm.
that's what we need to build with our grids. And if we understand our customers, we can offer them products and services that are much, much cheaper than trying to keep building more and more rigidity. Right. Why an octopus? I tell you what, we were originally going to be called Positive Energy. We had a great
Huh.
logo, by the way. I loved
Uh,
it. We loved it. Whatever your reaction. Anyway, our first investor was called Octopus Investments, and they agreed to invest an awful lot of money to build our big idea. A week before we finalized the investment, they said, "Would you call it Octopus Energy?" And we were like, "Oh no, slimy tentacle suckers!" It was before the Netflix Octopus Teacher, before the
right.
book.
Yeah.
Obviously, we wanted the investment. So, in good spirit, we went away and said, "How do you make an octopus cute?" And the answer was big eyes and short tentacles and a smile. And you know what? Just before they made the investment, they said, "Actually, please don't call it Octopus Energy." And we were like, "We're calling it Octopus." And I am
Here we
so
are.
glad because it's memorable, playful, and it's enabled us to make a real connection in an industry where so many people don't even know the name of the company that supplies them.
That's very true. Greg, you've been generous with your time. Have a great weekend. Thank
You've
you.
been brilliant. Thank you. Really enjoyed it. Thank you.
Cheers. Bye bye.